Assalamualaikum warahmatullahi wabarakatuh. Hi guys, today we will have chapter 6, current, resistance and direct current circuits. These are all the outlines of our chapter 6. We have 7 subtopics of this chapter. Let's take a look at the next slide. In this figure, if you can see here, the positive charges moving to the right, penetrating this area of A. These positive charges are moving perpendicular to the surface area of A, which could be the cross-sectional area of a wire. If you notice that this is the direction of current, moving in the same way of the moving charges. Let's take a look at the equations here. I is defined as delta Q over delta T. The current is the rate at which charge flows through this surface area of A. Suppose delta Q is the amount of charge that flows through an area of A in time interval of delta T, and that direction of flow is perpendicular to the area. Then the average current is equal to the amount of charge divided by the time interval. I is defined as delta Q over delta T with the SI unit of coulomb per second, or A, which is ampere. Since there are generally a very large number of charges involved in a current, it makes sense to define an instantaneous current with the first equation here. When the current is steady, the average and instantaneous currents are the same. Note that 1 ampere of current is equivalent to 1 coulomb of charge passing through an area of A in time interval of 1 second. Now we have 3 figures here: the upper left side, upper right side, and the bottom one. When charges flow through a surface area, like in these 2 figures, they can be positive, they can be negative, or they can be both. The direction of conventional current used in this book is the direction of positive charges flows, meaning that positive charges flows to the right, then the current is also moving to the right. The bottom figure here showing that this is a conductor. Positive holes in the lattice of the conductor's atoms as electrons move in response to a potential. Negative electrons moving to the left is equivalent to positive holes migrating to the right. Note that moving charges, either positive or negative, are referred to as charge carriers. For example, in metal, the charge carriers are electrons. For conductors carrying current, as charges move along a wire, the electric potential is continually decreasing. Delta U of charges equals to Q delta V. If you still remember, this equation can be found in the textbook. This equation is the same as the equation of 16.2 in our textbook. The decreasing electric potential means that the moving charges lose energy according to the relationship given here. At the same time, an energy of wire is deposited in the current carrying wire. If we take Q to be positive, then delta V is negative. So, delta U of charges equals to Q delta V is negative, which makes sense because the moving charges lose energy. Thank you for part 1.